Hello, this is the last video in this lesson, and it's on class activity 15C. Also, as you're going through this, I really encourage you to take advantage of the opportunities you have in the online course to really own your own learning. So what do I mean by that? I really mean it's your responsibility to be thinking about, are you learning? Are you learning in ways that are helpful? If you're watching all of my videos and you're not pausing them, or you're not speeding them up or slowing them down, and you're just going through them, if it's working, fine. But you could probably be more efficient. Play it on double speed, or maybe pause it, go back, watch parts of it. I'm guessing most of you are doing this already. In this activity and others, if you can tell that it's just kind of a practice activity and you've kind of got the idea, feel free to jump ahead. In fact, I would encourage you to pause this activity maybe after the intro of the problem. Make sure you understand the problem and then go through it on your own. And then if it makes sense and you can skip ahead to the end of the video and you can see, yeah, you're on the right track, there's no need to watch the whole thing. So here we go, class activity 15C. A little story. As a teacher, someday you'll probably inherit a classroom, and in that classroom will be a closet full of stuff or a cabinet full of stuff. And often you'll find these little plastic square tiles. They might be yellow and green, or they might be some other colors. But Mr. Lawler had taken 160 of these plastic square tiles. They're the same size, they're the same shape, everything's the same except some are yellow and some are green. He fills them up in this bag. This is my poor drawing of a bag here. Some are yellow, some are green. We don't know how many of each, but we know altogether there's 160 tiles. So altogether there's 160 of these tiles. He has a student come and select 20 of the tiles. So 4 of them end up being yellow, and the rest were green. And so down here I've drawn a picture of the student's hand and the tiles that are in their hand. So you can see 4 are yellow and the rest are green. So if there's 20 altogether, you should be thinking 16 green. And I maybe should double check, but I think there's 16 green and 4 yellow here. So he then is looking for the students to use this information to make their best scientific estimate for the total number of yellow tiles. This is actually somewhat similar to the problem I gave you in the discussion post on the Snickerdoodle Blizzard. How many do you think are in the bag based on this information, not on how much Mr. Lawler likes yellow or likes green, or whether this student tried to peek and get more greens, but really just based on this information. And so in the remainder of this video and this activity is asking you to really dig into how are students thinking about the problem. So again, encourage you to pause it here. I would ask you to watch the video where I talk about additive reasoning and in the next multiplicative reasoning, but otherwise if you're seeing the patterns, you don't have to watch the whole video. So pause it and take a look at the rest of it. All right, in this first example, the student is seeing that in 20 in the first handful, there were 4 yellow. And so I'm guessing the student is thinking if I took another handful of 20, I would expect to get about 4 yellow. Now, here's the variation. There might be more, there might be less, but since we don't know, we're going to stick with 4. 24, 24. We do this 8 times, and then we end up adding all of these yellow tiles up, and we ended up getting 32 yellow tiles. 20 times 8, there's 160 tiles total. In this next part, you can see a similar strategy, right? In 20 tiles, 4 of them would be yellow. So if I took 2 handfuls, that'd be 40 tiles, 8 of them would be yellow. 3 handfuls, I would have 60 and 12, and so on. Just keep repeating this process, each time adding 20 and adding 4, adding 20, adding 4. You might be tempted to skip and multiply, but this student isn't doing that. This student is adding each time to end up getting 32 yellow tiles out of 160. And I would say both of these students are using what we call additive reasoning. This is just helpful to know as a teacher. I'm not going to test you on it, but this really is relying on addition. And really, I say addition, it could be subtraction as well. And they're really repeating addition. Sorry, I'll slow down and write neater. And they're not multiplying. That's really the key here. So in both of these cases, this student, I think I said 20 times 8 is 160, but this student would probably do 20 plus 20 plus 20 plus 20 plus 20 plus 20 equals 160. And 4 plus 4 plus 4 plus 4 plus 4 plus 4 equals 32. And that is the key to additive reasoning. Multiplicative starts to really jump towards this multiplying. So starts to rely on multiplying. And another term that you'll see connected to this is proportional reasoning. To be honest, I don't know that I know clearly to define multiplicative versus proportional. They're similar. And you'll see that in this example. Of the 20 tiles, Taran picked 1/5 were yellow. So if we look at these, 1/5 of these are yellow. And that must mean that in the bag, if I had the bag here, that was really bad. I'm not going to try to draw it. If I had the whole bag, that must mean that 1/5 of the bag is yellow. And since I know 1/5, 160, that means that 32 tiles must be yellow. You see, this is very different than the additive reasoning here. This is looking at a proportion and multiplication here. Now, another way to look at this is thinking, well, Taran picked 1/8 of the tiles of the bag. This is 1/8 of the bag. Well, if that's the case, then this is 1/8 of the yellow tiles, which must mean the ones that she picked. If I took 4 times 8, that would give me 32 yellow tiles. One thing I love about this activity is it just really explodes how many different ways you can do this one problem. And this is great, not just from we can all do it the way that makes sense to us, but it's important for you to see as a teacher that your students are thinking in many different ways. And so if you force them to do the problem like this, but they're thinking about it like this, then you're not really helping them build off their prior knowledge. And they might think that this is wrong. Well, this isn't wrong, it's just a different way. You also, as a teacher, want to start connecting these ways. So maybe I'll try to do that here. How is this way connected to this way? Well, we can see here that, maybe I'll do it in a different color. This represents 1/8 of the bag. So instead of adding 4 8 times, we can use that reasoning to just take 4 times 8 is 32. And now you've helped this student connect their knowledge to this student who is using a different strategy, even though they're very similar. The strategies aren't similar, the foundation's similar. All right, let's take a look at a couple more. This is moving on to more formalization. If you see here in this example, the student is thinking of 4/20 as a fraction or a proportion. I would call it a fraction. But they're also seeing that they can scale that fraction up and it's still equivalent. So if I take the top and the bottom times 2, I get 8/40. If I reduce 8/40 by dividing, I still have the equivalent fraction. So it looks different It's written different, but it's still the same amount, the same fraction or proportion. And so we can just scale this all the way up until we get to the whole bag. So I would guess this student took it times 2, and then took it times 3, and then took it times 4, times 5, times 6, times 7, and then finally times 8, and said, aha, 160. I've got 160 tiles, 32 are yellow. All right, this next example we have a diagram, and if you'll notice there's 5 parts this way, and there's 1, 2, 3, 4, 5, 6, 7, 8 parts this way. And so we can see that the picture here represents the entire bag. And this is 1/8 of the entire bag. That represents the tiles the student drew. And you can see of that, 1/5 of the tiles are yellow, this part, and the rest, 4/5, are green. And so we see that in the entire bag, this must be 4 of the tiles. And it's a little unclear how the student was thinking if they took 4 times 8, but that would definitely work here. 4 times 8 to get 32 tiles. So in the whole bag, there's 32 yellow tiles. All right, 2 more, kind of relying on proportional thinking. This person, looking at the equivalent fraction 4/20, thought, I need to get a fraction where I have 160 in the denominator. So I'm guessing that this person thought 20 times what gives me 160? Oh, that's 8. So then I need to take 4 times 8, and that gives me 32 yellow tiles. Okay, and again, you see the connections between these thinkings. The last one here, this student thought about it slightly differently. They started with 4/20. They noticed that taking that 4 times 5 would give me 20. They didn't know how many yellow tiles there were, but they knew out of the whole bag 160, whatever that number was times 5 would give them the number of yellow tiles. So maybe they just tried different numbers, like, okay, well, 30 times 5 is 150, that's too small. 40 times 5, that's 200, that's too big. Maybe they just kind of did this guess and check until finally they landed on 32 to get that. Or they could have turned it around and said, oh, I need to take 160 divided by 5, and that gives me 32 yellow tiles. So either way, you could see there's many ways of thinking about it. It's important as a teacher to help your students move from additive reasoning here to multiplicative reasoning here, and then into equivalent fractions, which we see here and here, and then to start reasoning even more advanced about equivalent fractions here.